Hello friends, today's question. A uniform cylinder of length L and mass m having cross-sectional area A is suspended with its length vertical from a fixed point by a massless spring such that it is half submerged in the liquid of density rho at equilibrium position. When the cylinder is given a small downward push and released, it starts oscillating vertically with a small amplitude. If the force constant of the spring is K, the frequency of oscillation of the cylinder is. We are given that we have a spring, and to this spring a cylinder of length L is attached, and it is also given that it is submerged in the liquid. Suppose this is the liquid in which it is submerged. So we have to find out the frequency of oscillation if it is given a small downward push and then it is going to start to oscillate. So on this cylinder there will be two forces acting on it. One will be spring force. Let us suppose we write it Fs in upward direction, and there will be also buoyant force because of the liquid, and let us suppose which is represented Fb, that will be also in the upward direction. The total length of the cylinder is given as L, and the downward push given to the spring is, suppose it is displaced from its position of the equilibrium by a distance of x, then it will be submerged by a distance of x in the liquid, by which so the push to the spring will be equal to the amount of the cylinder which will be submerged in the liquid. Density of the liquid is given as rho, and A is the area of cross section of the cylinder. Force constant of the spring is given as K. So these are all the relative things which are given. Mass is given as capital M for the cylinder. So like we said, for the cylinder there will be two forces acting on it, and both will be upward, spring force as well as buoyant force. So first of all, let's explain the forces acting on the cylinder. So there are two forces acting on the cylinder during oscillation. Two forces acting on cylinder during oscillation. First will be the buoyant force Fb, buoyant force, which is Fp, and this is the upward force exerted by the liquid on the submerged portion. This is the upward force exerted by the liquid on the submerged portion of the cylinder. on the submerged portion of the liquid. Sorry, not of the liquid, but of the cylinder. Submerged portion of the cylinder. And second is our spring force Fs. And this is the restoring force. This is restoring force from the spring which also acts upwards. Also acts upward as cylinder oscillates. So it means we have two forces, Fs and Fb, which both are acting in upward direction. So we can say that since both forces Fp and Fs acts upward, the net force on the cylinder if it is given as F, this will be equal to Fs plus Fp. Now let us find out what will be the amount of the buoyant force and the spring force and substitute in this equation. Let's call the equation number 1. We come to the buoyant force. That is Fp so Fp, a buoyant force, is proportional to the volume of the liquid displaced, proportional to the volume of liquid displaced by the submerged portion of the cylinder, by the submerged portion of cylinder, which is given as X. So therefore we can write Fb will be equal to minus rho Vg, where rho is the density of the liquid, V is volume of the displaced liquid, and G is the acceleration due to gravity. And if X is the amount of the portion which is submerged, A is the area of cross section. So from here we can write that but V is equal to A multiplied by X, where this A is area of cross section. Therefore, we can write that our bound force, that is Fp, will be equal to minus rho AXG. So this is the formula for the bound force. Similarly, we find out the spring force, that is Fs. Spring force Fs, and this is proportional to the displacement from the equilibrium position, is proportional to displacement from equilibrium position. And the displacement from equilibrium position is also given as x. Therefore, we can say our spring force Fs is equal to minus of kx, where k is the spring constant. K is the spring constant. Therefore, the total force F, we substitute in equation number 1, you can say thus the net force on the cylinder using equation 1, we get F is equal to minus rho A xg plus kx, and let us call this equation number 2. Now, as it is going to oscillate, and we assume that if A is the acceleration of the cylinder, then we can write the equation for the motion for the cylinder. So if A is the acceleration of the cylinder, then the equation of motion for cylinder, you can say net force, which is given as F, will be equal to mass into acceleration. Net force F will be equal to mass into acceleration, and we also know that acceleration A is equal to omega square times x, okay, where omega is here the frequency of SHM, where omega is equal to frequency of SHM. Therefore, substituting value, we get that F is equal to m omega square times x, and let us call this equation number 3. So now it's quite simple. Now we have equation of net force in terms of mass, frequency and x, and we also have equation F in terms of the net force which is acting on the body, which is a summation of buoyant force as well as spring force. So you can say from equation 2 and 3, from equation 2 and 3 we get m omega square x is equal to minus rho a x g plus kx, or you can say that m omega square is equal to minus rho a g plus k. Therefore we are only interested in the magnitude, and therefore we can say that m omega square is equal to rho a g plus k. Thus we get that, and omega is equal to 2 pi f. So substituting here, we get that m 2 pi f whole square is equal to rho a g plus k. Therefore f will be equal to 1 upon 2 pi square root of rho a g k upon m. And in terms of the solutions which are given, we can write this as f is equal to 1 upon 2 pi rho a g x m whole raised to power 1 by 2. Okay, so this is the frequency of oscillation of the cylinder. This is the frequency of oscillation of the cylinder. And if you check the options available to us, we have here 1 by 2 pi rho g, sorry, here it is k, not x, my mistake. So we have 1 by 2 rho g a plus k and divided by m. So option number B is the correct option. So we can say option B is correct. Option B is correct. Okay. So this completes the question. Thank you.